Although both diamond and graphite are forms of carbon, graphite is a good conductor of electricity, whereas diamond is a poor conductor of electricity. In graphite, only three carbon atoms are directly bonded to one another through covalent bonds. As a result, bonding requires just three of a carbon atom's four valency electrons, while the fourth is relatively free and can move from one carbon to another. With these free electrons, graphite is a good conductor of electricity. Electrical conductivity of a diamond. Diamonds have no free electrons that can move and conduct electricity because of their tetrahedral arrangement of covalently bound carbon atoms. Since the existence of free electrons is required for a electrical conduction. As a result, diamond is a poor electrical conductor. Discuss the versatile nature of carbon. Special nature or versatile nature of carbon. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 million. It is more than the number of compounds formed by all other elements. Special properties of carbon are catenation, tendency to form multiple bonds, and isomerism. Catenation. The property of self-linking carbon atoms through covalent bonds in order to form long straight or branched chains and rings of different sizes is called catenation. The property of catenation is due to small size and unique electronic configuration and a great strength of carbon-carbon bonds. Here we can see straight chain, it is branched chain, and this is a closed chain of carbon element compounds. Tendency to form multiple bonds. Due to its tetravalency, carbon can form single bond, double bond, and triple covalent bonds by sharing 1, 2, and 3 pairs of electrons respectively between two carbon atoms as well as oxygen and nitrogen, etc. Isomerism. If a given molecular formula represents two or more structures having different properties, the phenomenon is called isomerism, and the different structures are called isomers. For example, here structures of a C2H6O. Here, if you see dimethyl ether and ethyl alcohol, CH3 CH2OH, it is called ethyl alcohol. CH3OCH3, this is called dimethyl ether. What are hydrocarbons? The compounds containing carbon, hydrogen in their molecules are called hydrocarbons. Example: methane CH4, ethane C2H6, C2H4 ethene, and C2H2 it is ethine, or this C2H2 is also called acetylene. Let us see alkanes and alkenes and alkynes. Alkanes, let us see all points. Hydrocarbons containing only single bonds between carbon atoms is called alkanes. See here, carbon carbon between single bonds are there. Next what? These are saturated hydrocarbons. They contains carbon carbon single bonds. General formula of alkanes, it is CnH2n plus 2. Examples of alkanes: methane CH4 and ethane C2H6. Let us see about alkenes. Hydrocarbons containing at least one double bond between carbon atoms is called alkenes. See here, carbon between one double bond. Alkenes are examples of unsaturated hydrocarbons. Carbon between double bond is there. So general formula of alkenes, CnH2n. Examples, C2H4, it is ethene. Propane, it is propene. C3H6, it is propene. Let us see about alkynes. Hydrocarbons containing at least one triple bond between carbon atoms is called alkynes. Here, between carbon and carbon, there are triple bond. Okay, so alkynes are examples of unsaturated hydrocarbons. So between carbon there exists a triple bond. Alkynes are the examples of unsaturated hydrocarbons. They contain at least one carbon triple bond. General formula of alkynes, CnH2n minus 2. Ethane, C2H2. Propane, C3H4. Ethane is also called acetylene. Okay. What is a homologous series? Write its characteristics. Let us see here. A group or series of hydrocarbons having same general formula with two successive compounds possessing difference of CH2 and with similar structures and similar properties are called homologous series. This is an example of homologous series. This is also an example of homologous series. Homologous series of organic compounds have the characteristic features. They have one general formula. For example, here given alkanes CnH2n plus 2, alkynes CnH2n minus 2, alcohols CnH2n plus 1 OH. Successive compounds in the series possess difference of CH2 unit. So, if a compound possesses these two properties, it is called homologous series. They possess similar chemical properties due to same functional group. Examples, alcohols, aldehydes, and carboxylic acids. Functional groups, if you see, COH, CHO, COOH. So, we may take alkanes, alkynes, and alcohols, aldehydes, and carboxylic acids, etc., as a homologous series. The individual members of a homologous series are called homologs. What is meant by functional group? Write some functional groups. The characteristic properties of an organic compound is depend only its atom group of atoms. It is called functional group. See, COH, it is alcohol group. Example, methyl alcohol. CHO group, it is aldehyde group. Acetaldehyde is an example. Chemical form of acetaldehyde is CH3CHO. Methyl alcohol, CH3OH. C double bond O, it is a functional group ketone, dimethyl ketone, CH3CO, CH3. COOH, it is carboxylic acid. It is acetic acid. The example is CH3COOH. COC, it is a ether group. Dimethyl ether is example. Chemical formula CH3OCH3. CNH2, it is amine group. Methyl amine, CH3NH2. This is methylamine chemical formula. COOR is ester group. Dimethyl ester, CH3COO CH3.